To solve a system, we can put it into an augmented matrix, then use Gauss-Jordan elimination to find the solution. So the steps we're going to do are 1. Put into an augmented matrix, and then 2. Use row operations to change the matrix to reduced row echelon form, RREF. So here is our linear system, and we're going to first put it into an augmented matrix. So first row is going to be the first equation, 4, 8, negative 4, and 4 again. Then the next is going to be 3, 8, 5, negative 11. And then the third, negative 2, 1, 12, and negative 17. So to get into reduced row echelon form, we need a diagonal of 1s. And I'm starting off with a 4 here, so I need to make this 4 a 1. So I'm going to multiply this first row by a fourth to get rid of the 4, make it a 1. So 1/4 row 1 for a new row 1, which means rows 2 and 3 stay the same. So 3, 8, 5, negative 11, negative 2, 1, 12, and negative 17. Now 1/4 times 4 is going to be 1. 1/4 times 8 is 2. 1/4 times negative 4 is negative 1. And then 1/4 times 4 is positive 1. So now that's a 1, which is good, but I need everything below it to be zeros. So I'm going to do 2 steps at one time. I'm going to multiply the first row by a negative 3, add it to row 2 to get this to be 0, thus also give me a new row 2. And then I'll multiply the first row by a positive 2, add it to row 3 to get this to be a 0, and thus also give me a new row 3. So 2 steps at once, negative 3 row 1 plus row 2 for a new row 2, and then 2 times row 1 plus row 3 for a new row 3. So all I'm going to get is to stay the same as row 1, so I can just copy that down. So 1, 2, negative 1, 1. And now to get my new rows. So negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 2 is negative 6. Negative 6 plus 8 is 2. Negative 3 times negative 1 is a positive 3. Plus 5 is 8. And then negative 3 times 1 is negative 3. Minus 11 is negative 14. So there's new row 2. Now onto row 3. 2 times 1 is 2, plus negative 2 is 0. 2 times 2 is 4, plus 1 is 5. 2 times negative 1 is negative 2, plus 12 is 10. And then 2 times 1 is 2, plus a negative 17 is going to be a negative 15. So far so good. I got my row of 1s here, or my column of 1s. Now I'm going to make this 2 and this 5 something easier to work with. So I'm going to multiply this 2 by a half and multiply this 5 by a fifth to make these 1s, thus also giving me a new row 2 and a row 3 again. So half of row 2 is going to give me a new row 2. Make that look a little bit cleaner. And then a fifth of row 3 for a new row 3. Again, row 1 is not being touched, so we're just going to leave it alone. 1, 2, negative 1, 1. So 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 times 8 is 4. And 1/2 times negative 14 is negative 7. 1/5 times 0 is 0. 1/5 times 5 is 1. 1/5 times 10 is 2. 1/5 times 15, negative 15 is negative 3. Now, I'm going to get rid of the 1 below this one here. I'm going to make this a 0. And to do that, I'm going to multiply a negative by row 2, add it to row 3 to get a new row 3. So negative row 2 plus row 3 give me a new row 3. Which means rows 1 and 2 stay the same. So copy those down. 1, 2, negative 1, 1, 0, 1, 4, negative 7. And now to get my new row 3. 0 and 0 is 0. That's easy. Negative 1 plus 1 is 0. Negative 4 plus 2 is negative 2. Negative 7 is a positive 7. So 7 and plus negative 3 is positive 4. Good. Now I got another 0 here. And so now I'm going to make this negative 2 a positive 1. So I'm going to multiply this third row by a negative half. So negative half row 3 for new row 3. Which means, again, rows 1 and 2 are not being touched. 1, 4, negative 7. And so negative a half and 0 is 0. Negative a half and 0 is 0. Negative a half and negative 2 is positive 1. Oop, that didn't come out right. There's 0. And then negative a half and positive 4 is negative 2. Clean that up. So now that looks nice and clean. I got my diagonal of 1s, but now I need to make everything above it zeros. So I need to make this a 0 and this a 0. So I'm going to do 2 steps at once. I'm going to multiply this by a negative 4 to add to 4 to give me a 0. And then I'm just going to add this to row 1 to cancel that 0, make that a 0 as well. So 2 steps again. So negative 4 row 3 plus row 2 for a new row 2. And then row 3 plus row 1 for a new row 1. So I'm getting a new rows 1 and 2, so which means row 3 doesn't get touched. So 0, 0, 1, negative 2. And now 0 and 0 is 0. Negative 4 times 0 is 0, plus 1 is 1. 1 times negative 4 is negative 4, plus 4 is 0. Good. Negative 4 times negative 2 is positive 8. 8 plus negative 7 is positive 1. So there's my row 2, and now row 1. So row 3 plus row 1, so 0 plus 1 is 1. 0 plus 2 is 2. 1 plus negative 1 is 0. And then negative 2 plus 1 is negative 1. So finally in the home stretch, just need to get this 2 to be a 0. So I'll multiply row 2 by a negative 2 and add it to row 1 to get my new row 1, and finally into reduced row echelon form. So negative 2 row 2 plus row 1 to give me a new row 1. So that means rows 2 and 3 stay the same. So 0, 1, 0, 1, 0, 0, 1, negative 2. And now 0 times negative 2 is 0 plus 1 is 1. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 0 is 0 plus 0 is 0. And finally, negative 2 times 1 is negative 2 plus negative 1 is negative 3. It is now in reduced row echelon form, so I can now get my answers from this equation, or from this matrix. X equals negative 3, Y equals 1, and Z equals negative 2. So the solution to this system is negative 3, 1, and negative 2.